Hello, I'm Anna Hankin. I'm a lecturer in the Department of Chemical Engineering at Imperial College London, and I specialise in a field called electrochemistry. So I look at how electrochemistry can help to solve some of the most pressing industrial problems. So on this slide, I've put a few pictures from the projects I've worked on. And the images on the left show electrochemical reactors of several sizes that were designed to recover nickel from industrial wastewater. Nickel is toxic, and so it's very important to extract it from wastewater before the wastewater is then discharged into the environment. And nickel is also valuable, and it's cheaper to recover it electrochemically than to buy newly mined material. And the reactors and processes I worked on ultimately helped to recover nickel from wastewater efficiently and economically. And the images on the right show a reactor built for splitting water into hydrogen and oxygen using energy from the sun rather than energy from fossil fuel combustion. Hydrogen is a clean burning fuel and can play a significant role in the future decarbonization of many industries. So what's common for all electrochemical systems? What are they? So in electrochemical systems, we supply electricity to effect some useful chemical change. So for example, this happens when we charge a battery. Or we can do it the other way around, which is to react chemicals together to generate electricity. And that's what happens when we use or discharge a battery. And I work on a wide range of electrochemical systems. But to go a little bit deeper into the example of renewable hydrogen production, I work on something called photoelectrochemical systems for water splitting. This means that water is split into hydrogen and oxygen gases using sunlight as the only energy input. The example on the left shows an established way of producing hydrogen renewably, whereby solar panels generate electricity, which is then used to power an electrolyzer for water splitting. But on the right is a two-in-one system where the functions of two devices are essentially combined in just one reactor. And designing materials and photoelectrochemical reactors is super challenging because there are so many requirements that have to be satisfied at the same time for these systems to work better than the two separate devices. And it's actually kind of like trying to finish a jigsaw puzzle where the pieces that are already in place keep popping back out, and it's hard to get everything right all at the same time. So it's quite what's called a non-over-constrained problem. So together with my colleagues, I do experiments and also formulate numerical models to try and understand how to optimize photoelectrochemical reactor design. And typically we start off by working on very small scale systems, studying individual materials and reactions, and then we scale up the system so that it's fully functioning, and we assess it as a function of time and various experimental conditions, and actually determine whether it's a good solution to an industrial problem or not. This research takes a very long time, and I've been working on this particular topic for more than 6 years, so I would say that patience and perseverance really are key. During my career, I spent a few years working part-time when I was a postdoctoral research associate, and the production of one of the reactors that you just saw on the previous slide was finished at the end of August. And there was 1 week that was extremely sunny, and we were really desperate to test this new reactor out under natural sunlight while the days in London were still fairly long and before the autumnal weather set in. And I didn't want to lose time, so I decided to bring my son into work with me on one of the days, and my colleagues all helped to look after him while the experiment was being set up and carried out. And here in the bottom picture, we're all crammed into a lift together with the pram and the equipment on our way to setting up the experiment on a rooftop. And my son was actually there when we got our first successful experimental result. And I have to say he was very well behaved, but my focus was still split into lots of different directions. So it's not something I do often. I enjoy participating in different outreach events, and we have had a stall dedicated to solar energy conversion on various occasions. So we've been at family-orientated events, so festivals like the Hydrogen Festival at University College London. It was a first of its kind festival dedicated exclusively to green hydrogen production. and we're also every year at the Imperial Festival. I also give a talk at the Pint of Science event, which is aimed at slightly older audience. But for the festivals, my colleague Dr Frankie Bedoya built a marble run to illustrate how an electron in a material becomes energetically excited when the material absorbs light, and how that same electron then participates in an electrochemical reaction. And every time, this is by far the most popular exhibit on our table. And I think it's mostly because it's very effective in keeping the smaller children occupied while we have conversations with their parents. I got my first laboratory in March 2021, so just a few months ago, and I'm currently in the process of buying essential equipment and various consumables and chemicals, and I can't wait to see the lab buzzing with research activities very soon. I write in more detail about my research interests and my ambitions on the website of my research group. The group is called Electrochemical Systems Laboratory, and the web address is at the bottom of the slide, so please check it out if you're interested to learn more. Thank you.